Water Resources Engineering 2, Unit 1, Gravity Dam. The base width for the elementary profile when the dam is safe in sliding. So, for no sliding to occur, the forces, that is the forces causing the sliding should not be greater than the forces resisting, means this is the frictional resistance resisting. So, now for the limiting condition, now these two forces are equal and opposite. So, for the no sliding, the frictional resistance. So, frictional resistance, that is the means mu times of the summation of V, where mu is the coefficient of friction, that should be equal to or more than the horizontal forces. So, this is the mu times of the summation of the V, that is the frictional resistance, and that will equal to means P, means that is the summation of H. So, mu times of the summation of the B should be more than or equal to means the summation of H. So, summation of the B means W minus U, because this W is acting downward and U is acting upward, and P means this is the horizontal forces, this means due to the water pressure. So, put the value of the W, U and P. So, then here is comes out the B should be more than or equal to H upon mu times of SC minus C. So, under the limiting conditions, that will equal to means B is equal to means base width is equal to H upon mu into SC minus C, and if the C is equal to 1, so means consider the full uplift pressure. So, then put the value of the C is equal to 1. So, this is the B is equal to H upon mu SC minus 1, and if there is no uplift pressure, means there is no water on upstream side. So, then the value of the C is equal to 0, and it will comes out the B should be more than or equal to, that is the H upon mu into SC. So, now here is the two equations is available. The first is for the no tension and other is for the no sliding. So, the minimum base width that will be provided, the greater than of these two equations. The stresses developed in the elementary profile. So, vertical stress distribution when the reservoir is full conditions. So, normal stresses, that will be PB maximum or the minimum, that will the summation of V upon B 1 plus minus 6 E by B. So, here this summation of the B means W minus U. So, put the value of W and U, and for the no tension, so then the E should be equal to V by 6. So put the value here. So for the full reservoir conditions, the normal stresses at the toe is equal to means PB maximum is equal to gamma WH into SC minus C, and at the heel so that will equal to 0. The principal stresses near a toe, that is the sigma, which is the maximum normal stresses in the dam. So sigma is equal to PB sec square alpha minus P dash tan square alpha when no tailwater. So then the P dash is equal to 0. So then sigma is comes out the PB sec square alpha. So sigma at toe with full reservoir condition in elementary profile. So sigma is equal to gamma W into H SC minus C sec square alpha. So gamma WH into SC minus C 1 plus tan square alpha. So gamma WH into SC minus C, so 1 plus B square upon H square. But the B by H or now B for the no tension, that will comes out the H upon under root of SC minus C. So B square upon H square means 1 upon SC minus C. So put the value of B square upon H square and solve it. So then the sigma is comes out gamma WH into SC minus C plus 1. So this is the principal stresses in the dam when the reservoir in full conditions. The shear stress is tau 0 at a horizontal plane near the toe. So tau 0 is equal to PB minus P dash tan alpha. Now when the P dash is equal to 0, so means no tailwater. So tau 0 is equal to PB tan alpha. Put the value of the PB at the toe. So this is comes out the tau 0 is equal to gamma H into SC minus C into tan alpha, but the tan alpha is equal to B by H from the figure. Put the value of B for the no tension. So this is comes out the gamma H SC minus C into 1 upon under root of SC minus C. So the tau 0 is comes out the gamma WH under root of SC minus C. So this is the two equations here for the shear stress as well as the principal stresses. The sigma and tau 0 is available. So then you can find out the value of principal stress and shear stresses for the elementary profile. So, this is the simple example or the problems which is based on the elementary profile of the Grapevity Dam. So, here design an elementary profile of Grapevity Dam to store the water up to a depth of 50 meter and assuming the following data. So, H, capital H is the 50 meter or H is the 50 meter. Uplift factor means C is equal to 0.8 and specific gravity of the dam material means SC is equal to 2.24 and the coefficient of friction means mu is equal to 0.75, and also calculate the shear stress and the principal stress at the toe by assuming that the E is equal to B by 6. So, then there is no tension. So, minimum base width according to the equations, suppose for the no tension. So, B should be more than or equal to H upon under root of SC minus C. So, put the value of H, SC and C. So, it will comes out the 41.67, and for the no sliding the B should be more than or equal to H upon mu into SC minus C. So, again put the value of H, mu and SC and C. So, it will comes out the 46.30. So, here the maximum of these two value of B, that should be the base width of the elementary profile. So, here this comes out the 46.3 meter. So, base width is equal to 46.3 meter, and here the sigma means principal stresses at the toe. So, this is gamma into H gamma W, this is the gamma W into H into SC minus C plus 1. So, put again all the values here, this comes out the means 1196.8 kilopascal or the kilo Newton per meter square, and also find out the tau 0. So, this is the gamma W into H under root of SC minus C. So, put value and find out the value of the tau 0. So, this is the sigma, tau and base width for the elementary profile. The practical profile of gravity dam. In the elementary profile of the gravity dam is only the theoretical profile. However, such a profile is not possible in practical, because now here the provision is to providing a straight top width for a road construction over the top of dam, and also providing a freeboard. So, what is the freeboard? Freeboard, that is the margin between the top of dam to the water surface. So, the providing a freeboard above the freeboard just above this elementary profile, or now you can say this is the water surface, so that the water may not spill over the top of the dam due to the wave action. So, addition of these two provisions will cause the resultant force shift towards the heel, because the more concrete is providing. So, the resultant force when the reservoir is empty was earlier passing through the inner middle third point. So, this will therefore shift more towards the heel, crossing the inner middle third point, and consequently the tension will be developed at the toe. In order to avoid the development of this tension, so some masonry will have to be added to the upstream side. So, addition of these two provisions, that is the freeboard and the top width, is means the providing the some additional concrete. So, then the means the resultant that will be the shifted towards the heel. So, providing the some extra concrete on the upstream side. So, the top width is taken as the 14% of the total height of dam. So, how to find out the total height of the dam? Total height of the dam means the depth of water plus freeboard, and this freeboard is taken as the 3/2 height of waves, 3/2 into height of waves, or not less than the 1.5 meter. So, then the total height is comes out the depth of water plus freeboard, okay, and the top width is providing that 14% of the total height of the dam, and generally taken the 14% of the height of the total height of the dam, or now may be provided the 6 to 10 meter. So, this is the problem which is based on the practical profile. So, design the practical profile of a gravity dam of stone masonry. So, given the following data, the reduced level of the base of the dam, that is the 1450 meter, and the reduced level of HFL, that is the 1480.5 meter, and the specific gravity of the masonry, that is taken as a 2.4, and the safe compressive stresses of the masonry, that is the 1200 kilonewton per meter square, and the height of wave is the 1 meter. So, if this height of wave is 1 meter, so freeboard, that is the 3 by 2 into height of wave. So, this is comes out the 1.5 meter, or the less criteria, that is the 0.9 meter. So, which is more. So, here is providing the 1.5 meter. So, then the RL of the top of the dam means the 1480.5 plus 1.5. So, this is the 1452 meter. So, total height of the dam, that is the 1482 minus 1450. So, this is comes out with 32 meter. So, limiting height of the dam, that is the now that we will discuss in the next article. So, this is comes out the F upon gamma W into SC plus 1. So, this is the comes out the 35.4 meters. So, this means this dam is the low gravity dam. So, depth of the water is taken as the 1480.5 minus 1450. So, this is comes out the 30.5 meter. So, the base width for this elementary profile is B is equal to H upon under root of SC. So, this is comes out the 19.36, and the total height is comes out the 32 meters. So, 14% of the 32 meter. So, this is the 4.5 meter, and the additional concrete is provided the A by 16 at the heel. So, this is 0.28 meter, and now these the two factors means giving the some slopes 2A under root of SC. So, value of the A is the 4.5 and SC is known, and the 3.1 under root of SC. So, this is the means make this slope. So, means this is the additional concrete which provided here. Okay. And now, this is the some additional problems are given that draw the practical profile of a low gravity dam for the following data. So, height of the dam, total height of the dam is known, means 31.5 meter, and the specific weight of the concrete is known. So, this find out the SC also, the safe compressive stress is given, and the top width is given. So, top width is given means 3 meter. So, means on upstream side providing the concrete means A by 16. Okay. So, this is the A, and height of wave is 1 meter. So, providing the freeboard. So, after means the freeboard, this is the 1.5 meter. So, 1.5 meter is the deducted from the total height of the dam. So, then find out the base width. So, this is the problems. Low dam and high dam. So, the principal stresses for a gravity dam having elementary profile, that is the sigma is equal to gamma W into H into SC minus C plus 1. So, here SC and C for a particular given condition will be constant. So, the value sigma varies directly with the height of dam. So, means sigma is directly proportional to the H. So, to avoid the failure of the dam by stressing, the value of sigma should be less than or equal to the allowable compressive stress F of the material. So, this F is equal to sigma is equal to gamma W H into SC minus C plus 1. So, H is equal to F upon gamma W into SC minus C plus 1. For the lowest value of H in the above equation, in the equation, so then put the value of the C is equal to 0. So, that is the no uplift. Thus, the obtaining limiting height, the uplift is to be neglected, and then the H limiting is equal to F upon gamma W into SC plus 1. So, if the height of the dam having an elementary profile of a triangle is more than the above equation, so the maximum compressive stresses generated will exceed the allowable value. So, additional concrete is providing on upstream and downstream. So, that will comes out the stresses within the limit for the height. Thanks.